Hey everyone, welcome back to another video. Today we are going to be exploring molecular geometry. So after today we're going to be going over the valence shell electron pair repulsion, otherwise known as our VSEPR theory, but also more importantly we're going to be describing the shapes of these molecules and kind of go over the reason as to why they make this shape. All right. And so that's kind of our goal for today. So let's go ahead and get started. So right now we have one singular atom. And so far we've been learning a lot about covalent bonds, okay? Everything that we're going to be talking about today is going to be in reference to these covalent bonds because these are molecular geometries. So right now I'm going to select the molecular geometry and the electron geometry name. And I'm going to include two of these. Actually, let's even do one. All right, we're going to include one other atom, and it doesn't even matter what it's bonded with. You could see that regardless of what it's bonded with, it could even be a triple bond, that it's going to be making this line shape. And that line shape is just going to be linear, okay? And so I'm just, for the rest of this video, I'm just going to be using just only single bonds, but notice it doesn't matter if I use these single, double, or triple bonds. It's always going to give me the same molecular geometry. Okay, so anyways, these are going to be called a linear shape. So if you have two atoms, those are going to be making that linear shape. Okay, if you have a third atom, you are also going to then have a linear shape. So now watch as much as I'm trying to get it to touch that other atom, you can see that it's kind of repulsing it, right? And this is all according to that VSEPR theory, or that valence shell electron pair repulsion. And this is the point of this, is so that way the electrons on each of these atoms are trying to get as far away as possible from the other one. So no matter what I do, they're always going to be trying to get away from that other atom. So if I add another one, you can see that it makes a trigonal planar shape. So right now we could count 1, 2, 3, 4 circles in total, or 4 atoms. And therefore, that is going to make that trigonal planar shape. If I continue to add more, this is going to give me that tetrahedral. And I'm actually even going to show these bond angles. You don't have to know these bond angles, but you could see that if I were to remove one, it's always going to be maximizing that angle from which those are going to have. All right, so this is going to be my tetrahedral with 1, 2, 3, 4, 5. And then after that, we are going to have our trigonal bipyramidal shape. The reason why we have that is because we have a pyramid on top followed by a pyramid on the bottom, therefore the bipyramidal. And then lastly, the one that has a lot of shapes is going to be known as our octahedral. This is going to be the very last one that you guys will need to know based off of these shapes. Okay, so octahedral is going to have all of those. It's going to have in total 1, 2, 3, 4, 5, 6, 7 total valence, or 7 total atoms, and so on. Okay, just so you guys know, at the very end of this video, I'll be also showing you guys the little cheat sheet that goes along with it. All right, so let's go back to our linear shape with two of these, in total 3 atoms. And I'm going to add a lone pair. Remember, the lone pairs are going to be all about the lone pairs are going to only really care about our central atom. So right now, if I were to add a lone pair, you could see that the shape that it makes is going to be trigonal planar, but this lone pair, because the lone pair is pushing these atoms down, causing it to make this bent shape, okay? So that's going to be the name that this is going to be taking place. If I were to add another one, so another lone pair, okay, the electron geometry, it would be very similar to making a tetrahedral shape, right? Where you could see that if these were considered lone pairs, we have our little bent atoms down there. But instead, we have 2 of these lone pairs. Now we have this, what we call a bent shape, okay? Even though that it looks like a tetrahedral of some sorts, okay, if I were to place it like that, these don't count as atoms. So it is going to consist of that bent shape, all right? So actually, let me keep that up. So now let me remove my lone pairs. Let me get another one right here, and I were to add one of these lone pairs on top. Once again, it would look like a tetrahedral, but the actual name for it is going to be trigonal pyramidal, or a pyramid shape, right? Because we have a nice little pyramid going on. No, we're not going to go into T-shape or anything like that. And I think that might be all the ones that you guys need to know, if I'm going to be honest. Let me add one more. No, but this is my favorite one. This is seesaw, because you got a little seesaw going on, right? Beep, beep. Anyway, so those are going to be all of the ones that you need to know. You didn't need to know seesaw. Those are going to be all the shapes that you kind of needed to know. And let me drag this over just to kind of show you guys the ones not necessarily needed to know. So here is just kind of a little cheat sheet. Here you're going to have your total number of atoms, and I would suggest writing this in your notes. You're going to have your total number of atoms, and so as you go down, you can see that it makes that electron geometry shape of linear, and then the molecular actual name is going to be linear. Here we're going to have no lone pairs, so we have a trigonal planar shape, but if we have one lone pair, that makes that bent shape. Once again, you don't have to know the angles. Once we get to tetrahedral, right, with 4 atoms, then we got tetrahedral shape. Now we're going to still have 3 atoms, but include 1 lone pair. It still makes that tetrahedral shape, but now it's going to be called a trigonal pyramid. And then lastly, with 2 lone pairs and in total 3 atoms, that's going to make that bent shape. Okay. After that, right here, you don't have to know the seahorse. You don't have to know T-shape. You don't have to know this linear after you get trigonal bipyramidal. Very similar with octahedral. You don't have to know any of these. Actually, let me draw the ones you don't need to know. So you don't need these. You don't need to know these. All right. These are the only ones that you need to know for the rest for the class. All right. So anyways, I hope this helps. Do what you're doing with your covalent bond worksheets, and you're just identifying